For this one, I'd like to bring on Anna to talk about decentralized data and how do we make that way better by leveraging AI and having AI leverage decentralized data. So without further ado, let's welcome Anna and we'll get started. Anna, good to have you back.
Hey, yeah, great to see you.
All right, we'll get you all set up and you should be good to go in a second.
Great. Okay, I think I can get started then. So yeah, today I'll be talking about kind of the role of data in AI and how you can access better data through kind of decentralized data for training better AI agents and better AI models. Oh, and I'm one of the creators of Vana, which is a protocol for data sovereignty that kind of makes your data portable across applications and allows you to pull it into data DAOs so you can all collectively own your data and kind of contribute it towards AI models. So AI models are kind of ultimately only as good as their training data, right? If you post on Reddit, you might have already helped to train some AI models. This is a breakdown of training data of GPT-3, but represents kind of a lot of the foundation models' large training data sets. Most of it is from the public internet. So common crawl means you kind of just like scrape all the internet that's publicly available, kind of put that in a data set that then you train on. And this is generally how AI models learn today. And then sometimes there's like a fine-tuning step at the end. Something to note here, though, is that this represents a very small percent of the overall data that exists because such a small portion of the internet is publicly scrapable. So people estimate that that's less than 0.1% because most of the internet requires permissions or sign on to access. So if you want to use that data to train on it, you need to broker some kind of deal with a company that has access to the data in today's kind of centralized Web 2 world. One of the problems that AI researchers have kind of started to talk about in the past year or so is called a data wall, which basically refers to the fact that we're actually running out of training data to use to make AI models better. So here I'm kind of showing as AI models have gotten better and smarter, they've been trained on more data. Often people only think about the compute side of the equation of like scale up compute. But if you're scaling compute, then you also need to scale data. And so that's actually this limitation that we're running into, where Llama 3 is trained on around 15 trillion tokens of tokens as in words in an AI context of data. And the whole public internet, if you dedupe it and just take the high quality stuff, it's a data set called FineWeb. That's around 15 trillion tokens, right? So we're kind of at max capacity of all the data that we can find on the public internet. So the question becomes like, okay, what next? Like, how do we get more data? Something I'd mentioned too that I think has been like an interesting angle that DeepSeek has brought in is that the data wall is both an issue of like quality and quantity. And DeepSeek actually managed to kind of like overcome this data wall through quality. So they hired like a team of PhDs to generate really high quality cold start data. People say people say basically their founder was labeling data himself, and that's just like how seriously they took data quality for that starting data set that then they can kind of train on. So when you think about what kind of data you want to train AI model, there's both this aspect of like, how do you get the most data and how do you get the highest quality data? And to date, before DeepSeek, it's been like a pretty brute force approach, which is kind of like scrape the whole internet. You know, that if you imagine being like a kid and you can only learn from the public internet and you have, I don't know, you're like reading 4chan or other public forums, like it's not the best information, but maybe if you consume a lot of it, it's okay. But you can also go the approach of, okay, from a very large subset of data, let's narrow in on extremely high quality stuff and use that as this training. So that's just sort of to set the ground for what makes good data in training AI models and how things are done today. Companies have realized that their data is extremely valuable in this AI world. and they've really locked down their data, right? So Reddit's earning $200 million from selling data, PhotoBucket $1 to $2 an image, Apple's buying news data for like $50 million. And if you are like a company acting rationally that has very valuable data, like often the thing that will allow you to charge the most for your data is to shut down access for other people, right? So the internet is kind of becoming less and less open. Like Stack Overflow and Reddit both kind of changed their API terms. And I feel like now more and more you run into, I don't know, these sign-on walls where it's kind of harder for you to get access, because those siloed platforms are building bigger walls to protect their valuable training data. There's one group that still has access to this data that most people don't realize, and that's actually users. So as a user, you legally own all of your data in the same way that when you put your car in a parking lot, the parking lot doesn't own your car. It's still your car. You can take it back anytime. When you put your data in a platform by like tweeting or writing a message or posting an image, that's still entirely your data. When you sign the terms of service, you're signing like a very permissive license with them to say, hey, you can use my data for the purposes of like operating the service. Some of them have added this clause related to like training an AI model as well. But sort of the default state before the terms of service is it's entirely yours. After the terms of service is they have access to it, but it's still yours. And you can always go and get a copy. So if you use like Alexa in the past, you can actually go export your Amazon data and like hear every single audio recording, which is kind of like a creepy experience. But I think it just shows like they have all this data on you and it's yours. You can always go take it back. Instagram is also kind of a fun one because you actually get back both your like posts, messages, photos, but also the AI labels that they've put onto you. And so you can see kind of like what categories they've put you into, and can be kind of interesting. But what's important about this is because each user legally owns all of their data, you can actually have users kind of export their data from across different platforms and actually build like bigger and better data sets than any single company can, right? Like if you have, say, all of Apple and all of Facebook and all of Google, they're not all going to work together. I mean, there are also kind of regulations where they can't share your fully private data and kind of connect it across you. But the user is actually able to get more data across those platforms. So that's like this group that often people forget about that really has true legal ownership over the data that's sitting in the walled gardens. Vana is this self-sovereign data layer for AI that's really designed to unlock data from those walled gardens. So two of the core features of Vana, one is like non-custodial data. What that means is that you can manage access to your data just like your funds while preserving privacy, right? And this privacy piece is actually really important. One, like, because if you want to put private data and kind of permission it on chain in some way, like I don't want my messages or sleep data to all be fully public. So kind of just from a user preference perspective. Second is more from an economic perspective, where if your private data becomes public, there's not really a reason for someone to buy it from you anymore because it's just publicly available, right? And so that privacy piece is really important to allowing for these like economic markets to be able to form around data. And then second is proof of contribution. And so when you have one person's data, it's not that useful for training an AI model because you need a lot of data to actually be able to train. You need 10,000, 100,000, 10 million even users worth of data to be able to create something kind of very substantial. So how proof of contribution works is it basically allows a large group of users to contribute their data to a pool. And data is different for everyone, right? Like it's necessarily non-fungible. That's like what makes data data. My data is different from your data. And so there's kind of this question of like, well, when we put our data together, how do you prevent like a malicious actor from pretending to be 100 people who are contributing their data? Or how do you weigh like one person's data versus another? And so that is the mapping of proof of contribution, which is implemented at the data set level. So every data set, every data DAO has their own proof of contribution. And if you are a developer on Vana, you might already know the term data liquidity pools, DLPs. That's this more technical term, which basically is referring to the aggregated data set and kind of smart contracts around it. And you might also know the term data DAO, which is, so from a technical perspective, you could have a DLP that's not technically a data DAO. So every data DAO is a DLP, but a DLP is a slightly more flexible kind of technical term where you can aggregate data that's potentially not managed via a DAO, or potentially kind of like operates with a stable coin or something like that. So just to give you some examples of data DAOs across the ecosystem, here are a few of them that I just kind of pulled up. YKYR is a Chrome extension. And yeah, I'll mention this too, where when you interact with Vana, you will probably interact with an application that's built on Vana. That's like the front end that you'll see. So yeah, YKYR is a Chrome extension. Sleep.fun has you connect your sleep data. Prime Insights is having you connect your Amazon data. That verification is actually kind of interesting, where you download a Chrome extension that they offer, and then you export your Amazon data, and it actually generates like a zero knowledge proof client side to prove that the data actually came from Amazon. So there are a bunch of different verification methods that have plugged in, like there's ZK email, Reclaim has a ZK TLS thing that kind of plugs in. And then there's also a set of TEs where you can run general Python code to essentially verify data quality. So if you're building with some kind of like verified tool in mind, there could be interesting ways for you to plug into the Vana ecosystem and allow data DAOs to better kind of verify their data. There's just kind of this spec for a proof of how you have to exactly write the proof on chain, but it's relatively general. So yeah, I think there's some really interesting stuff happening there. Maybe one other one I'd call out. Yeah, there's a Telegram data DAO here, and then Nowhere is your Google Maps location data. And a lot of this data is very private, right? And so that kind of like security piece really matters. So I can actually talk through how it works when you connect data too. So when I connect data to say Nowhere, or like there's a Spotify data DAO called Unwrap, I'm connecting my data there. First thing I do is log in with any EVM compatible wallet. That's what kind of manages my keys. And then I grant access to my data in some way. Sometimes it's OAuth, sometimes it's a Chrome extension or a manual upload. And then I sign a transaction to basically retrieve an encryption key that I use to encrypt my data client side with a key that I control. And so then I write that up. I store that to storage that I control, actually, so you can connect your Google Drive, your Dropbox, kind of any storage that's self-sovereign that you own. There are also some more convenient storage options if you don't want to host it yourself. Then you write that on chain and essentially have that pointer to your encrypted data. Then when you're joining the data DAO, what you're doing is basically saying, hey, my data meets your proof of contribution. And so then the data is verified through a TE or by checking the proof to show, hey, my data is actually legit. It's good to join this. And then what you're doing is you're encrypting your data with a key that the data DAO controls. So you've essentially delegated access to the data DAO to be able to make decisions about what happens to your data. Just to highlight some of the data DAOs, the Reddit one has like 140,000 Reddit users. 1 million people tried to join. So this shows that kind of proof of contribution is working, right? There were 1 million wallets, but only 140,000 kind of like real Reddit users who have an account, have the Karma minimum. And now they've trained a user-owned LLM, which is primarily just good at shit posting because it's trained on Reddit data, but is kind of like that starting point. Another one I'd call out is the 23andMe DAO that actually aims to like buy 23andMe and make it user owned. That is a massive undertaking, right? But I think that that's actually an interesting example because their goal with a data DAO is more like negotiation and leverage versus purely like we want to sell our genetic data. It's actually we don't want to sell our genetic data. So those are the sorts of things that are possible with data DAOs built on this kind of data liquidity pool primitive on Vana. Something else I'll call out that I mentioned a little bit already on the privacy side is that data on Vana is private, but it's interoperable, right? Often when you want interoperability, you have to trade privacy. Like if you look at most of the decentralized social protocols, the solution, which makes sense for a sort of like public social protocol, is that they make everything public, right? So like Blue Sky or Farcaster, like it's basically like the data is all public. In the case of Vana, we are really designed for private data, but still making it interoperable, because I think a lot of the like information that you want to bring to an application, whether it's context for an LLM, like your past messages, photos, like even a clone of your voice, that you don't want to make fully public, right? Like people want that privacy, but they also want that interoperability. What that means as a developer is that there are two ways to access data on Vana. So one of them is individual access. What that means is that a user can sign in with their wallet to your application and bring their data that they've already onboarded to different data DAOs or different applications into your application. So they could bring like their sleep records and Strava records and nutrition records into your like health AI application. And you can then kind of make much better recommendations based on that information. The other way to access data on Vana is through kind of this aggregate access, basically accessing all of the data from a given data DAO. And so, for example, you can train an AI agent on a whole data DAO's data set. One example of a data set that's kind of interesting is Finquarium is one of the financial data DAOs that's built on Vana. And they have people aggregate their exports from centralized exchanges. And often that data set you don't really have access to, right? And so like usually you can only see the on-chain stuff. And then as soon as it's in a centralized exchange, you don't really know what's going on. But if you train an AI agent on Finquarium's data DAO's kind of data set, then you have access to that private data that wouldn't otherwise be available. So I think there could be opportunities in that case to build like a better AI trading bot because you have access to data that like nobody else has access to. Something on the privacy side I'll mention too is that only the outputs, so like the inference or the trained model, can leave unencrypted, which ensures that the underlying data stays private, right? Often whenever you're like letting someone use your data or potentially like working in a data sales context, if I give you my data, it's really hard for me to know that you haven't resold my data. We call this like the double spend problem for data. And the way that we solve that is that you essentially only work with data in a secure environment and can run general Python operations on that data, kind of get what you need, but you never have that unencrypted data actually leaving the environment. And so, yeah, if you're interested in accessing any of the data from the data DAOs or building with individual data, both of these things I'll say are not that well documented on our docs right now, and is something that we're kind of rolling out this quarter. A lot of the sort of fully self-serve stuff that's easiest to do right now is building a data DAO more on data ingress side. The other thing I'd mention about data on Vana is that it's structured and quality checked, right? Often when you kind of imagine this like self-sovereign, like interoperable internet, one question becomes like, what's the structure of all the data? Like, how do I as an application know even what I'm consuming and what I can build around? And so each data liquidity pool on Vana, kind of data DAO more informally, is defining their data set structure and their proof of contribution and verifying that all the data that they're writing proofs about is actually of the format that they're expecting. So this one data schema I've pulled is from sleep.fun, which is a sleep data DAO. If you have an Aura ring, you can contribute your data. I think they support a bunch of different data sources too. So if you have like a Fitbit or an 8 Sleep, you can also contribute your data. They have a leaderboard. It seems like people aren't sleeping that well recently. So if you're a good sleeper, it would be great if you could join the leaderboard and kind of make sleep.fun healthier and sleeping better. But yeah, this is their format. So then as a developer, you know what data you're getting, right? And then it's also quality checked. So you know that the data that you're accessing has gone through whatever the proof of contribution implementation is. So you can know, okay, this is actually good data that comes from users with a real account of at least this age. and sort of have that information, because data quality kind of matters so much in training better AI agents and better AI models. So the best way to get started on Vana is to either start a data DAO or access data. Something a lot of people don't realize about starting a data DAO is you can start one for like any data source of your choosing, right? Because the user has the legal right to go and get their data from any platform, you don't need anybody's permission to start one. You can just choose a data source and like go and have users export their data and kind of start contributing. So in terms of the steps, scoping out your data source, picking one, picking how users will contribute. Every data DAO has their own data set specific token. So there's also a question of kind of how you want to reward users relative to each other. Reddit, for example, does it based on the square root of your karma. The 23andMe one, I think, is treating users all equally. I'm not sure if the Spotify one rewards people if they have like a premium account more. Some of the financial ones reward you more if you have more trading volume. I think one of them rewards you more if you've like lost more money. And I am not sure exactly what the rationale is there, but it's sort of like, yeah, basically you're mapping a bunch of users and their data to like how much should it be worth relative to each other. We have a Discord too. There's actually a session this afternoon where we'll be going into some specifics around like data tokenomics, so feel free to jump into that. Then there's a process of building, so kind of deploying smart contracts. There's some templates in Solidity, proof of contribution, which is implemented in Python, and the interface for users to contribute data. On the interface side, there are a bunch of different templates you can clone. So if you're looking to make like a Chrome extension or a web application, there should be something in the ecosystem that is relatively easy to start from. And then there's also some stuff where people are building like a unified UI to be able to contribute across different data DAOs. So that's something that's in the works as well, to make it a little bit easier to start. And then you can launch. So you basically deploy your contracts, have your application ready, kind of register with the like DLP registry on Vana. So then everyone can find your data DAO, know about it, know what your data structure is, what your proof of contribution is. And then you can also compete into the top 16 data DAOs on Vana, which are actually earning a share of emissions because they're onboarding data into the network, right? Often these kind of self-sovereign data ecosystem projects, which it kind of, I think, a little bit the original promise of Ethereum and crypto more broadly, like own your data, own not just your funds, but all of your information across like a self-sovereign internet, really fail to reach like mass adoption. And so I think that it's important to have this way to like bootstrap bringing users in with their data through data DAOs. So then developers can build amazing applications. Some of them are data DAOs, but some of them are also just accessing the data that data DAOs have brought in. Most of the teams building are like 2 or 3 people. Initial build takes a few weeks. You can probably create a template data DAO in a few days. And if you're looking for ideas, I've listed some here. Like I'd love to see an iMessage one, TikTok, medical records. I also posted like a wish list over the holidays, maybe a month or 2 ago, on data DAOs I would love to see. So that would be a good starting point too. And so, yeah, here I've got a link to our docs. The QR code is specifically the page on how to build a data DAO, as well as our Twitter. The other thing I'd mention is accessing data. So if you'll be at ETH Denver, we're actually hosting a hackathon where we'll be showing kind of a preview of a lot of the data access and data portability. And if you have a use case you're already building for, definitely get in touch and we can kind of like get some early feedback on exactly the kind of like developer endpoints that we set up for data access. The last thing I'd mention is if you want to learn more about Vana, a great place to start is actually the white paper. That's linked in the doc somewhere. And so feel free to dive into that if you want to more understand it at a high level, or if you want to dive into building, these docs are a great starting point.
Awesome. That was such a good overview, Anna. Thank you so much for doing that. A couple things I'm curious about are just understanding, in at least the last 6 to 8 months, how have you seen more AI and agentic experiments on the data repositories at Vana, and kind of what's been super interesting to see from your community?
Yeah, I think that the AI agents. So one thing that maybe I'd say actually has surprised me recently, I think today or yesterday, someone built a plugin to Eliza where they're letting AI agents actually trade data tokens. So like the AIs can buy their own data, and that I think is not directly like it's like actually giving AI agents like direct access. So that's been interesting. And then there are other applications. I think more trading applications than I like otherwise would have guessed or predicted. Where
Trading
you're
the
basically
data itself, or trading based on understanding and parsing the data from the DAOs?
trading based on understanding and parsing the data from the DAOs.
Oh,
Exactly.
super cool. Wait, so
So
where
those
is
are
the
some of
inference
the
happening?
applications that have been really interesting to see.
So does that mean they're taking the data and then modeling and inferring somewhere else and then doing the modeling, or is it something different?
Exactly. So it's the two to look at here are DataPig and Finquarium. And so what they're doing is essentially aggregating the data to teach an AI agent to be a better trader. And then having that AI agent kind of operate on its own. One of the other ones I would mention is YKYR. They have a Chrome extension where they're kind of collecting a lot of your browsing information, better understanding you, and they're building this personal agent that's based on how you typically browse the web and a deep understanding. And they're doing everything actually like client side in the Chrome extension. So they recently got, I think, a small version of DeepSeek running client side in that
Wow.
Chrome extension. So that's been cool to see and kind of preserves the privacy.
Um, how, so this might be a dumb question, but
No,
how
no,
do
yeah.
you ensure the integrity of the data that's being taken from the DAO to do inference and do fine tuning and then run the models? And kind of does the protocol help with the data integrity in this way? And if so, kind of where does that come into play for these bots?
Yeah. Data integrity is like almost the most important thing, where if you're like working with bad data, then you're going to get really bad AI, right? And so you need to know and have some guarantee around data quality and what you're consuming. And where that's enforced at the Vana level is through proof of contribution. So every data DAO, any data point that comes in needs to go through proof of contribution, which is ensuring a whole bunch of checks on the data. So one of them is like proof of ownership. Does the user actually own it? One of them is like proof of authenticity, where you want to check, did this data point actually come from the source I'm expecting it to come from? And then you have to check kind of uniqueness and quality as well. And each of the data DAOs implements that themselves with a set of tools that makes it easy.
Gotcha. Okay. Um, and how does this now interact with other chains here? And is it kind of enforcing that things have to be sort of moved offline or off chain to move forward, or does that mean we actually are now also looking into cross chain communication and simplifying this whole agent universe?
Yeah, so there's actually like a tight interlocking between the data DAO and the off-chain compute, right? Where usually the situation you end up in is like, okay, the DAO approved something, like now what? Like now how do you like trigger some compute to happen? But actually, like so what you have is like a TE that has the key that the DAO controls and is checking, okay, has the DAO voted to run code in this environment and for us to decrypt the data? If yes, data is decrypted and the code actually runs. So you end up with a really tight interlocking between that like off-chain compute environment that's not it's not optimistic or ZK based. It's actually just purely like, okay, it's in a TEE and you have a guarantee that this is going to run without the data leaving, right? Often that's the problem where ZK or other proofs, they can tell you something about the data, but they can't prove to you that it didn't leak, right? And so that's this really unique like compute environment that
Oh, that's pretty
makes
cool.
the data more like interoperable, composable while preserving privacy.
I think that's a really, I mean, this is a really key feature for you to actually guarantee actual safety around what's the output and make sense of it. So I'm glad that he ended up actually covering that, because I didn't even think of it in terms of like pointing that out. That's awesome. Well, I want to thank you again for this amazing presentation, and for everybody on the live stream still continuing to build on your hacks for this weekend. Feel free to check out Vana and using data DAOs.
Awesome. Thanks so much.
Thanks, Anna.